In April 2010, we initiated a graduate project to look into the disposal options for boilers at Berkeley site. Approximately 22 graduates got involved, split into various teams, business case, size reduction, health physics, transport, to pull together a study on the feasibility of disposal of these boilers. This is a very big project for Berkeley. It's very visible. It's going to make a very big visible difference to site. We haven't got a very big team on it. We've got a very small project team, a project manager and a couple of project engineers and a bit of project controls to manage the work. This is the first phase of the project, removal of the boilers from site. There's lots of work to follow on in the treatment stage. The main challenge we've faced are somewhat around historical records. We've also set ourselves some challenging timescales. We set this out right at the start of the project. From April 2011, we set ourselves a challenging date for award and of the contract to do the work, and we worked very well together with Low-Level Waste Repository to meet that date, which was the 4th of November. We've carried on that passion in the team, if you like, to keep driving the programme, making sure that we try and achieve our dates, and that's been one of our main challenges, but working together we've managed to get this far.
Berkeley boilers are being taken to a purpose-designed size reduction and smelting facility in Sweden. There's only a couple of places in the world that have such facilities. One's in America and one's in Sweden. Because the market for the smelting of radioactive waste is small, it's an international market. So there isn't enough in the UK to warrant having a facility just specifically for the UK. So that's why they've ended up going to Sweden rather than being treated in the UK.
Studsvik has been recycling low-level metallic waste at our facilities in Sweden for over 25 years. We've treated a large number of similar boilers and heat exchangers from nuclear power stations in Sweden, Germany, Finland, Switzerland and now from the UK as well. The recycling of low-level metallic waste is well established as the best environmental option and is fully consistent with the government policy on waste and the NDA's National Low-Level Waste Strategy.
There are 3 separate transport activities on this scope of work. The first one you'll see is the transport from around the reactor building through to a temporary laydown area. This site transport has its own challenges in terms of negotiability on the site and the capability of the site routes to be able to take the movement of the load from where they are into the laydown area. The next phase is probably the most complex phase in terms of movement off-site and to the port. And this really has involved quite a big team of people back in head office working with the Highways Agency, working with the local authorities and the police and all of the strategic partners involved to get the permits and the planning arranged to allow us to move from here to the port. The final phase for transport is the movement from the port onto the vessel that's going to take the boilers to Sweden.
The boilers will arrive via ship to Studsvik's own deep water harbour within our nuclear site boundary. And there they'll be transported to a storage area. Each boiler will then be transported into our specialist large component treatment hall where they will be size reduced using a range of purpose designed and developed engineered tools. The metal will then be shot blasted and then melted for a further treatment step before being released for recycle in the Swedish scrap metal market.
The waste materials from the recycling process are segregated out, so you end up with clean material which can be reused back in general industry, and then you get what we call secondary waste. Secondary waste is packaged up in accordance to its category, which from the boilers we expect to be low-level waste, and it's sent back to the UK for disposal. So that bit of the boiler will come to LLWR for disposal, but the volume, as opposed to sending the whole boilers, is about 10% overall. So as you can see, there's a huge reduction and a huge benefit in doing that. So the wastes are still going to be effectively managed and responsibly managed and brought back to the UK. So we're not sending the waste overseas to be disposed of, we're still dealing with the UK's radioactive waste disposal over here.
The biggest challenge on this project that we faced have been the quite aggressive timescales involved in delivering this project from its conception 5 months ago to moving the boilers off-site. We've had to spend a huge amount of time designing the safe system of work that we've looked at in order to handle the units, and we've also had to work very closely with our customer and the end customer as well as all of the stakeholders involved in the transport, to make sure that we can put together the safest, lowest risk concept. ALE has a huge amount of experience doing this type of activity, but usually we would face years of planning rather than weeks or months of planning that we faced on this project.
Moving the boilers is going to have a major impact because it's going to happen on a trading day. The whole area has been talking about how the boilers are going to be moved, the size of them. We've discussed everything that's got to happen. We've been fully engaged in how they're going to come through Berkeley.
We strongly believe the success of any project, and especially this project, is down to the cooperation, teamwork and synergies between the strategic partners that we're working with. The integrated project team that we've seen on the Berkeley Boiler project has worked very well and allowed us to have great success in the short timescale that we've had to mobilise and deliver this project. And I hope this success will carry through to the delivery through to Sweden over the next few weeks.
I believe this project can really show how the nuclear industry can work together to deliver high-profile and challenging technical projects. A lot of preparation work has gone into this project, a lot of teamwork, and the planning and preparation for this project has been strongly supported by all those involved. I think teamwork has been a key factor in this project, and the results for that can be clearly seen.
Moving the boilers is going to be a major milestone in the decommissioning of Berkeley site. It's going to have a visual impact on the site, and it's the ultimate in the recycling project because they're going to be removed, the steel is going to be reused, and it's the ultimate recycle, reduce and reuse.
I think if you talk to anybody in the industry this time last year and said, will we get 5 boilers off site by the end of this financial year, the answer would have been no, that's too difficult. But actually look where we are, that's been achieved. So that's a great testament to the fact that we've worked incredibly closely together to achieve what was thought of an undoable project.
My background's in civil engineering. I'll be very satisfied to see these boilers go. Civil engineers like to go around pointing at things that they've done, built, removed, and it'd be great to come back here one day and look at the empty site.